We will work on chapter 12 in class exercise 5, problem number 1234. This is on page number 21 of your handout. So for this problem, let's read the problem statement. The platform is rotating about the vertical axis such that at any instant its angular position theta is given as a function of time. A ball rolls outward along the radial groove so that its position changes as per the given equation. Determine the magnitude of the velocity and acceleration of the ball at t equal to 1.5 seconds. So see, we have both theta and r parameters, and that indicates that we need to use either cylindrical or polar coordinate system. Now, how do we decide which one to use? That depends on what is the type of motion. Is the motion only on a plane in 2 dimension? Then we use polar coordinate system. Or if the motion is 3 dimension, then we use cylindrical coordinate system. And in this case, the motion is in 2 dimensions, so we will go with polar coordinate system. To calculate velocity and acceleration, we will make use of the given formula, where velocity has radial and transverse component, and Vr is r dot, and V theta is given by r theta dot. Acceleration has these two terms, radial and transverse, where radial acceleration is given by this equation and transverse acceleration is given by this equation. Now, for all these equations, we have number of parameters such as r dot, r double dot. We also have theta dot and theta double dot. So first step is we will calculate all these parameters at given time period, which is 1.5 seconds, and then substitute their values into these equations and get the velocity and acceleration components. Okay, so let's define the coordinate system. So radial component of the coordinate is in the radial direction, so r. Transverse component of the coordinate is in this direction, that is theta. Unit vector here is ur, and unit vector here is u theta. Okay, so let's write down the formula, which is r equal to (0.1) t cube. This is given in the question, so we will derive the formula for r dot. So r dot is derivative of r relative to time, dr by dt. So derivative of this is 0.3 t square, and then we have r double dot, which is one more derivative of r. So it's d square, or second derivative of the position. So d square r by dt square, which is one more derivative of this term, and that is 0.6 t. Now we are calculating everything at specific time at 1.5 seconds, because that is being asked in the question. So at t equal to 1.5 seconds, you substitute 1.5 here. So value of r is 0.1 multiplied by 1.5 cube, and that is 0.3375 meters. For r, the unit is meters. R double dot at 1.5, sorry, r dot at 1.5 is 0.3 multiplied by 1.5 square, 0.675. This is r dot, so it's meter per second. R is meter, t is in seconds. R double dot is 0.6 multiplied by 1.5, and that is 0.9 meter per second square. So we have calculated all three parameters for radial direction. We do the same thing for theta. So theta given as 4 multiplied by t to the power 3 by 2. So we don't need actually the value of theta in any one of this problem, in any one of this formula. See, there is no theta here, there is theta dot. So theta dot is derivative of theta relative to time, and that is 6 multiplied by 2 t to the power 1 by 2. And theta double dot is derivative of this relative to time, which is 3 t to the power minus 1 by 2. So this is called angular velocity, this is called angular acceleration. and at t equal to 1.5 second, theta dot is 6 multiplied by 1.5 power 1 by 2, and that is 7.348 radians per second. Theta is measured in radians, so this is radians per second, and this is radian per second square. Theta double dot is 3 multiplied by 1.5 minus power 1 half, and that's 2.449 radian per second square. So we have calculated all the required parameters, and now it's time to substitute them here in this formula. So this is the velocity written as a vector, but the magnitude of that velocity will be square root of r dot square plus r theta dot square. So let's write this. So velocity magnitude is equal to square root of r dot square plus r theta dot square, which is nothing but the square root of two components, addition of square of two components of the vector. So all we need to do now is we need to substitute the respective numbers here. So r dot we have here, which is 0.675 square, plus r, which is 0.3375 multiplied by theta dot, which is this number square, and this is 2.57 meters per second. This is the velocity of the ball at the given time, 1.5 seconds. For acceleration, we have another formula, which is square root of radial component square plus transverse component square, which is r double dot minus r theta dot square whole square. See, be careful with this formula. This r theta dot minus r theta dot only square, that's the part of the equation, but we have to do the square of the whole thing for vector magnitude calculation, plus r theta double dot plus 2 r dot theta dot whole square. So similar to the above formula, we need to substitute the numbers that we have calculated at 1.5 seconds. For example, r double dot here is 0.9, okay. And r, we already know that 0.3375, theta dot is 7.348, again r theta double dot, and then other terms. So substitute all the numbers here and calculate the magnitude, and that's 20.40 meter per second square. That is the total acceleration of the ball. So steps: define the coordinate system, calculate all these parameters, and substitute them into respective equations and get the magnitude. Thank you.